Hey, today I'm going to teach you about solution stoichiometry. So what stoichiometry basically is in general, it's just a relationship between the relative quantities of substances in a reaction. So it can be between the reactants, it can be between the reactants or the products, or interchangeably between the reactants and the products. So let's just go, we're going to start off by going through the steps of regular stoichiometry, and then we'll figure out how solution stoichiometry differs. So first you want to balance the chemical equation to make sure your ratios are correct, and then you want to convert what you have to moles, and then you're going to use a molar ratio to find out the moles of your target, and at the same time you're going to find the limiting reactant. And then your last kind of step is to find the target unit of what you want. Where solution stoichiometry differs is in this step and in this step, where instead of having masses or grams or something, you'll have you'll have like liquids in milliliters or liters, or you can have concentrations or anything. So to start off, we're gonna do two practice questions kind of. And here's the first one. What volume of 0.125 molar sodium hydroxide aqueous is required to react completely with 15 milliliters of 0.1 molar aluminum sulfate? And what molar means is just basically moles per liter. Okay, so to start off, we balance the chemical equation here. Do this in blue. So we balance the chemical equation so that the elements on each side are equal, and then we kind of wrote down what we had right here. That's horrible. But whatever, we wrote down kind of what we have here, and then next our step 2 was to convert to moles, and we used this formula right here to figure out the moles. So we had the volume and the concentration, so all we did is multiply them to get the moles, and we got 0.0015. And then we figured that out, right? But we had to jump over to this side to find out the volume of NaOH, which is right here. We had to find this. And to jump over to this moles, we had to use the molar ratio. So basically, to think it out, you would divide it by 1 and multiply it by 6. But to use like an actual equation, we used the moles of what we had, and then multiplied it by 6 and divided by 1, the molar ratio right here. And we got 0.009 moles. So then we got this, and all we had to do is jump over to this, and that's also where it differs from step 4 target unit. We also use this formula, but instead of finding the moles, we found the volume. So we just did volume equals moles divided by concentration, and we got 0.072, but that's in liters, and we were given milliliters here, so we have to convert it to milliliters. And that's 72.0 milliliters, because we have to add significant digits for communication wise, because we're given 3 significant digits in all the parts, and we have to include 3 significant digits. So that's one question. Let's go through another question real quick. Oops, go over here. Yeah, that's enough. So calculate the number. What am I doing? Calculate the number of milliliters of 2.0 molar HNO3. Whoa. Yeah, of 2.0 molar HNO3. That's not that. It's supposed to be this. Calculate the milliliters of 2.00 molar HNO3 solution required to react with 216 grams of silver according to this equation. So it was already given to us in balance, so that was step 1. Step 2 was to convert to, and we also kind of wrote out what we were given. So we did moles, volume, concentration, mass, etc. So what we did is we converted to moles in step 2, but we couldn't use this to convert to moles because we didn't have enough variables. So we used this, and we used the molar mass. So we just divided the mass by the molar mass and got 2.00241 moles, and we always use 5 decimal points for molar numbers, whatever it's called. And then we had that, right? But we had to jump over to the moles of this, in order to find the volume. So we used the molar equation, and again, in both of these questions there's no limiting reactant, but what you would basically do is in this same step find the limiting reactant, just as you would for a regular equation. So basically, to think it out, we would have to divide it by 3 and times it by 4, but in the equation we did 2.0024 moles of Ag divided by 3 and times by 4, or you can reverse it, but this is the molar ratio. We got 2.66988 moles. That's what we got, but we had to jump over to this, and again we use this equation that we were given in this last question, and we rearranged it so it was volume equals moles divided by concentration divided by 2, right, because that's our concentration. Molar again means moles per liter, and we were given 1.335, but that was in liters, so it was asking us for number of milliliters, so we multiplied multiply it by 1,000 to get 1,335 milliliters, and that was our final answer. And that's it.